Today's video is going to be concerning becoming prepped and ready to do the heating and cooling curve lab. Just recently we went over what a heating and cooling curve was, and now what we're going to do is we're going to go ahead and have a lab to go ahead and test that idea that we just went over recently. And to remind you, the idea that we recently gave was we said that we can go ahead and take a substance, we can heat it, and then it's going to stay constant temperature-wise as it's going through a phase change, which is something that should be, a little bit disconcerting, or something that you don't quite expect. You don't expect that if you give something the same level of energy that it's going to stay the same temperature. So that's what we're going to be doing here. We're going to actually be testing the hypothesis that when you heat or cool something, that while it's going through the phase change, its temperature is going to stay the same. Okay? And what we're going to be doing that with is a heating and cooling curve lab. Now, in this lab, we are going to be using a substance that's called stearic acid. And stearic acid is a pretty large acid in terms of how many atoms are in it. And we're going to be heating it up and making it go through a phase change, and then we're going to be cooling it down. So we're going to turn it into a liquid, and then we're going to go ahead and go from a liquid to a solid. So this is our big thing that we're going to be working with. We're going to be using hot plates instead of a Bunsen burner for this one, because the hot plates end up giving a little bit more constant temperature to our beaker. And we're going to go over a couple of the things that I want you to watch out for in this lab. This lab, we are going to be doing data collection. And for each lab that's a data collection lab, we're going to have one person in the group that's assigned to do that data collection initially during the lab, and then they're going to share it to everyone. So everyone is going to end up turning in this lab report, though there's only going to be one person collecting the data on the actual lab day. For this lab, I'm going to be concerned that you are going to be wearing goggles. I don't really feel the need for aprons on this. Stearic acid isn't actually all that caustic. And we're really going to be using just the beaker. You're going to have 2 thermometers that you're going to be using throughout this thing. And then you're also going to be using a stopwatch or timer, and many of you are going to be able to use your phone during this to accomplish that task. Okay, we're going to have a relatively large test tube, and we're going to have water. Now, for step 1 is going to be us preparing the cooling curve. Okay. And the idea here is that we're going to go ahead and heat this stearic acid up until it is completely a liquid. So we want to start our experiment with liquid stearic acid. How you're going to do that is you're going to go ahead and take a beaker, you're going to fill it with water, and you're going to heat that water up until it reaches about 95 degrees Celsius. Okay. What we're going to do once we do that is we're going to go ahead and place the test tube in the 95 degree water. Okay. So we'll have the test tube, we're going to place it in the 95 degree water, and inside the 95 degree water, we are going to have our stearic acid. We are going to go ahead and stir that with the thermometer until all of it ends up being turned into a liquid, until all of it melts. And then we're going to make sure that we get the thermometer to a temperature of about 95 degrees Celsius. Okay, we don't want it to go higher than 95, we want it right at 95. So our thermometer is going to be in with the stearic acid, and we're going to get it to 95 degrees Celsius. Okay. Then what we're going to do is we're going to go ahead and take that test tube out of that hot water bath. Okay. And as soon as you take it out of that hot water bath, you are going to want to start your timer. That's 0. So your very first time for this is going to be 0, and at 0 it should be 95 degrees Celsius. Okay, because it's 95 degrees Celsius when you pull it out. You're going to pull it out, that'll be your 0 time. You are going to continue to stir your stearic acid while it's in the test tube using your thermometer, and every 30 seconds you will be taking another measurement. And you are going to record what the temperature is there after that 30 seconds. And you're going to keep doing that until you reach a temperature of 30 degrees. Okay, so every 30 seconds until you reach 30 degrees. And 30 degrees Celsius is going to be, slightly warmer than room temperature, because that's what your overall goal is. Your overall goal is to go ahead and take it from that 95 degrees to about room temperature, and that's where we're cooling, okay? At some point, the thermometer is not going to move anymore. That is okay. If you are having trouble with the thermometer moving, that is okay. You want to make sure that the thermometer is still in contact with the stearic acid, though. Okay, so you don't want the thermometer just hanging out there in the test tube, not touching anything. You're measuring the temperature of the stearic acid. That's the most important thing. Now, some words of advice, especially for the cooling curve. The cooling curve, you need to keep your thermometer moving. So your thermometer is going to be moving the entire time during the cooling curve. You don't want to just move the thermometer when you're doing the temperature. You want to continue moving it throughout the entire thing. After you have completed the cooling curve, then we're going to go ahead and start with the heating curve. Now, the heating curve is going to have your water, and your water needs to be probably about 85 to 90 degrees. Your goal is to keep that water at 85 to 90 degrees, okay? Oftentimes what happens is that the water ends up getting way too hot, and it will end up messing up some people's experiments because they'll be adding more energy to the water, and the energy added won't be constant. We need to make sure that when we're heating it, we keep a constant amount of energy being added. Okay, so you want to keep it at about 85 to 90 degrees, and you're going to do the exact same process. You're going to take your test tube, you're going to place it in the water, and you're going to keep it in the water so that the stearic acid is, below the water line. The stearic acid is going to stay in your test tube, so please don't try to dump the stearic acid out of the test tube. And you're going to stir it and then record its temperature every 30 seconds. You're going to start by recording the temperature at 0, which is right before you put it in the water. Put it into the water and then stir and record it every 30 seconds. Okay, that's what the experiment is. And you are testing to see whether or not you get this curve or not. Now, if you end up getting all of your information, and you're going to record it here. This is going to be your cooling side. This will be the heating side. Okay, so cooling, you're going to go all the way down. Maybe it'll take 13.5 minutes, maybe it won't. Heating, you're going to go all the way down. Maybe it'll take 13.5 minutes, maybe it won't. Then what we're going to do, we're going to go ahead and plot our data. And you can plot your data on this one right here. And you're going to go ahead and do it in 2 colors. For the heating curve, you're going to do that in red, and the cooling curve, you'll do that one in blue. Afterwards, you're going to go ahead and answer these questions. You're allowed to use your group mates to help you explain these questions, but each person is going to be answering these questions in their own words. And that will be the end for this lab right here. Again, if you have any questions, make sure to ask me before the lab begins. And the other thing that I want you to note, that especially when you are graphing your data and writing down your lab observations, you need to make sure that you're recording exactly what you see. Okay. Don't try to fudge any data just so that it matches what you expect to be getting with the heating and cooling curve. Remember, we are testing to see whether or not this assumption is valid. And if you get data that says that it's not, that is still valid data. You may want to think about ways that, you could have messed up that data, alternate explanations. However, your data is still going to be exactly what you see. All right, this is going to be the close for this video on the heating and cooling curve lab.